Hi, this is Kenneth Wong, Senior Editor for DE 24/7, reporting from AU, Autodesk University in San Diego. This year, the spotlight is again on AI. This should not come as a surprise considering Autodesk's recent acquisitions related to AI, like Blink AI. But at AU this year, we get to see proof of concept of how the company might incorporate AI into its own design products. Now here's a preview of Project Bernini on the show floor. This is the application called Bernini, reinterpreting my simple clunky 2D sketch of a house into a 3D model. You can almost see it thinking, filling the sketch with volumes, and here's the final result. It's a pretty good 3D concept. It matches the basic idea I had when I sketched the house. It seemed to understand the basic structures of chimney, windows, and roofs. Now let's learn more about the conceived workflow with generative design enabled by Project Bernini.
Yeah, so these are miniature chairs that were generated by our Bernini model that we then 3D printed. And so it shows up as sort of an art installation actually, but it shows kind of the variety of chairs that we can get out of the model. Project Bernini uses generative AI to generate 3D models. So we're using text, we're using sketches, we're using voxels, we're using point clouds, and from all of those we can generate better 3D models. And so for someone who uses Fusion, you might imagine, or Inventor, you might imagine sort of a first pass, like a conceptual, idea generating sort of thing. When we use Bernini, you get several choices, several options out, right? So it'll give you ideas, sort of like maybe if you're using Midjourney or something similar with 2D. My team, the AI lab at Autodesk Research, we're working on getting 3D generation to be more and more precise, so much maybe more useful for engineers going in the future. For now, though, we're sort of solving the more conceptual problems, the things that are a little less precise, but again, we need to solve the science of that before we can make it more precise.
We also had a chance to speak to Yosuhide Yokoi, Chief Design Officer of Final Aim, which uses natural language prompts and generative design applications to design a mini truck for Japanese farmers, a project he did for Yamaha.
For this case, we collaborated with Yamaha Motor to come up with a design specifically for Japanese agriculture. And here is the final version of the design, which has been actually produced as a prototype, but still has a functional detail that can be utilized even starting tomorrow. And here, I'm showing some of the images that were generated through the design development. Actually, more than 2,000 concepts, 2,000 ideas were generated within 2 to 3 weeks. Of course, some are very abstract, some are very, specific. But on the other hand, we need to communicate well, we need to interact well so that AI really understands, AI really responds to the issues that relate specifically to Japanese agriculture. I'm based not only in Japan but also in the US, half and half, and also I grew up in Australia, so I know the cultural sense between the West and the East. And for example, if I type in some of the aesthetics related to Japan, and this, AI, generative AI that's been created by tech giant, it looks at a glance, this is very Japanese. But if you look at every details, it's completely wrong. And I'm not saying this is in a bad way. This is, still in an evolving phase, still in the development phase. But the point here is who and how is developing this generative AI, especially on the cultural aspect. Of course, the language, the word, and the nuance behind, the subtle differences behind is completely different depending on languages, especially the difference between Japanese and English, as all you can imagine.
In content creation, the use of natural language prompts is starting to replace manual 3D modeling.
So imagine that you need a scene for doing a photo shoot. This is an office environment. You need to populate it with table, chair, computer, other stuff that you will have. So Shutterstock has library of licensed models, millions of models, right? So we use Shutterstock, which is using NVIDIA Edify 3D to create these 3D models. This can be just using a prompt that you enter, and it will give you that accurate 3D model, photorealistic 3D model that you can use to populate the scenes, like you see in this case, the watch or the computer, the keyboard and such. All of that has been generated using AI by using text prompts.
And we're using this integrated into Maya here today to be able to simply prompt and very rapidly populate a scene for this virtual product photography shoot that we're building here in Maya. I'm in the 3D model tab, and I could just put a simple prompt into here. For example, let's say we want a toy decorative race car. I can put as my prompt for generating a toy decorative race car 3D model. I want something that's a bit of a decorative thing that I can put on the desk here, right? And then of course we have what we call a negative prompt, and that is what I don't want it to be. And this Shutterstock plugin allows me to take advantage of that. So I can say, I'm going to put in, this is the opposite of what I want. I don't want it to be cartoon. I don't want it to be ugly. And I could expand on that. We'll leave it as that. I could even upload a reference image here, whether it's a drawing that I've done or a reference photograph perhaps I've taken, another render of something I've created, whatever it may be. But I could just use text, or I could use a combination with that reference image as well. And the key takeaway here is we're using NVIDIA Edify technology to generate that 3D mesh, but it's trained on this very deep, massive library of Shutterstock assets. So if you're familiar with Shutterstock, you know they have a massive library of amazing imagery. And all of the images that we're using when we generate here, it's trained off that. And that is important because that is licensed, vetted imagery. It's not borrowing or taking from someone else's creation. We're using a vetted library of assets, and we're doing that with 3D meshes as well. It's actually trained on a huge library of TurboSquid assets. There's the toy car there, and I'm just going to place it onto the desktop the way that we're used to working in Maya here. Let's place this right down flat, and there we go. That's not too bad of a little asset that we've generated. And you can see that it's all quad geometry, pretty clean mesh. And overall, if I just deselect that, we have a nice little prop that we've added to our scene.
Now, just as getting the shape and geometry of the design is getting easier, so is replicating the texture of the materials in real life, such as leather or fabric.
So Captis is essentially a material capturing device. So starting from a physical sample, you're able to capture not just the color, but really all sorts of physical properties of that sample, such as the surface details, right? So if you look at the material itself, we see, of course, it has the color, but also if we look closely, you have all these, kind of surface details which we want to capture. It also has the roughness quality. It may be transparent, translucent. So with Captis, all of that is kind of done for you. It's a kind of single-click solution. Maybe this letter sample, right? So when you open up Captis, you can see over here that we have a tray, which is for your physical sample. So we'll remove this guy. And then let's go and position this thing over here. You can use magnets to really secure it. All right. So once we have this material scanned, then we can continue working in sampler, and we can continue kind of adding procedural parameters. For instance, if you want to add something like stitching, or you want to change the color, you can do that after the fact. So you're going to have your physical sample, but then you can kind of continue working in a creative sense. And then we can really kind of analyze, what's the roughness quality of this material, and we can try to, kind of mimic this roughness in sampler. So for instance, let's say that I want to make it, even shinier than what it is right now. I can go to the base material, and you see I have the roughness value. So I can just kind of drop this value to something lower like this. Now we have something that's really, really shiny.
Along with the design and simulation software, AU also features lots of hardware makers offering systems designed to process the new AI-driven workloads.
So it's really about building a balanced system that can serve your AI needs, development, or inference at the edge, in whatever form you'll need now and in the future. So that's really our story today, from our mobiles to our towers, and even our rugged systems featuring the new Core Ultra processors from Intel, unlimited turbo, neural processing units on board the chipset, along with the performance and efficiency cores.
So what's really important for AI workloads are really two accelerators, the CPU and the GPU. And what we have here is we have our Intel H-series processor, and that's really got three different accelerators on the CPU. It's got the CPU for high throughput, the GPU for bursty performance, and then it's got an NPU for low power AI inferencing. And all three of these accelerators work together to provide AI workloads that are accelerated for Intel Silicon. And what we're doing is we're taking these three AI accelerators and we're enabling them for different ISV software to deliver new experiences and to increase performance.
So inside of here we've got the capability of having 3 double-wide GPUs inside of there. So that's a great feature for customers that really want to have the power to develop, render, or use AI initiatives in there. We've got a full stack of memory we can have in there with the Xeon processor. So we've got enough memory to actually allocate to all the different processes and have enough base clock speed to actually keep everything pumping along at a real great rate. When you're doing AI, there's lots and lots of different large language models that are available, or machine learning, the amount of data that you need to process. The more memory you have, the larger the models you can have, the more accurate your data is going to be. So workstations now, again with this one having 3 48 gig cards inside of it, or we've got our ThinkStation P10 that can take 4 of 48 gig cards, you can have much larger large language models working for AI at the desktop. And then once you exceed that, that's when you then start moving into the data center and using Lenovo servers to actually get bigger and bigger data sizes in there for larger models.
That's a wrap from AU. For more design and engineering news, visit us at Digital Engineering 24/7. That's digitalengineering247.com. For now, I leave you with some snapshots from the show floor. And I'm Kenneth Wong for DE.